All right, so let's talk about some generic steps in solving the problems when you don't have the nice easy point formulas. So the first thing that you should do is write the problem down, draw the problem, because that's going to give you way to the step number 2, which is to declare the coordinate system. Then create the differential, dq. Step number 4 is to create, basically you need to define little r, whatever the distance is from dq to whatever other charge is involved there. So you're basically going to create the temporary things. You're creating little r, theta, that's the temporary variables. And again, I say mean temporary in the fact that they will not show up in the final one. These are things that are not given in the problem itself, but things that have to exist. And if you look at some of the examples, I think you'll see that that's the case. Step number 5, plug into formula. And don't forget, if you're finding force or electric field, angle definitely becomes critical. Unless you can argue it away by symmetry arguments, as they do some cases. And then get variables in terms of a single variable. And then step 7, do the calculus. Now, there are some shortcuts that can be taken, as we talk about in some of the other videos, but just some of the other ones, these are some shortcuts. So this is generic, and these are the shortcuts, some shortcuts. 1, if you're outside spherically symmetric charge, then you can assume that this is a point charge. That's the nice simplest case. 2, if you're inside a spherically symmetric charge, ignore charges farther from center than you are. You are, it's the point charge, whatever the point in the question is, wherever that point is. 3, if there are symmetries, you can exploit that with Gauss's law of electricity for the most part in this course. And then 4, if applicable, and that makes it incredibly vague, but if applicable from your point of view, same you as in that, so I guess your, in quotation marks, your point of view, treat as point charge. And what I mean by that is, if I have let's say I have a cylinder that has a charge distribution on it. Now I cannot assume that I don't have spherical symmetry. I do have some symmetries, though. I potentially can exploit Gauss's law, but not necessarily. It depends upon where I am in that. So if I have a can of charge and I'm trying to figure out what is the charge, when I'm near one corner of it, I cannot exploit that kind of symmetry. If I'm, smack dab in the middle of it, I have a little bit better chance of it. However, if I'm far enough away from this can of charge, which does not have a uniform charge distribution, then I can treat it as a point charge if I'm far enough away. Now the question is, how far is far enough away? And that's some of the stuff that we'll explore, and that's a test question that I've asked in a couple of them, where I take an infinite line of charge, then I take a finite line of charge in very similar situations. And part of that is experience, and part of that is, it's sort of implied in the language of the question. So, which I guess also goes along with experience. So that is some of the generic steps or some of the shortcuts. Now this right here, I will do that derivation for you in another video. And the exploiting of the symmetries, we will exploit some of that when I derive the electric field for certain situations. And then this one we'll just sort of pick up as we go.